Okay, let's take PPassAB, let's set it back to all, so it's always going to evaluate all the connections between all these particle groups. And this is iterative, so every red particle that we have in the scene, if we had more than one, every red particle would go through and calculate against every green particle, and kind of do a comparison there. But anyway, we want to look at PositionFollow for what it does. Right now our constant speed, again, still too high. Let's try this other method. Instead of constant speed, let's use a spring. And you can see right away those green particles jump right in behind. That's because our spring laziness is 0. There's no kind of spring effect. We'll start to increase that, and what we'll see is that right around up in the high 90s, we can get a nice spring effect. Let's actually go 98%. So it takes them a while. They do a little spring back, come together, and then they start chasing after them again. There's things that we can do with offsetting values as well. Let's say we have a constant speed method, and we start to adjust the x offset. It's going to have these particles be following that position with this offset. So 10 to the right of wherever he is. As well, we could do minus 24 in the y direction from where that particle is. And remember, these are in world space. So if you ever have to modify them, you're going to you might need to calculate the local particle alignment. And then of course let's switch this top view. If we added a z offset, it's going to put them up above there. So just remember, these offsets are going to be for whatever the position coming in. It's going to be like a position offset from that position. And you can actually expose these parameters. Go ahead and do that now. We'll do visible all and PositionFollow. We can see everything that we get available to us here. So here's that offset, x, y, and z. Type, of course, is an integer. You had to have 0 for constant speed and 1 for spring. Okay, and the other thing is lock axis. Lock axis is going to allow us to prevent the particles from responding in any of these particular axes. Let's go ahead and remove that offset first, and let's go ahead and see. Let's say we don't want the particles to actually change in x at all, so we'll go ahead and lock x, and what will happen is now they're only going to follow in y and z, so they do not kind of head inward in the x-axis at all. And if we wanted to prevent them from moving in the y, we could do that as well, but that doesn't make a whole lot of sense because our red particle doesn't actually go up in z at all. We could make him do that and see what happens. So let's change this around. And now they'll actually follow in z, but their x and their y axis, they're not going to move at all. So that's pretty much the basics of PositionFollow. It's great because it can use other particles as well. You could remove that and say we want to affect the green particle. And you could also, again, use a node and use the node's position to follow as well. Let's see, we must have an issue here. Oh yeah, the lock is on. So PositionFollow, very flexible because it can just use a generalized position information. You could have it be a node. You could use PPassAB, the initiator, so you can compare between two different groups or more. As well, you could also feed in just an animated 0.3 value. So if you wanted to animate this over time, then those particles would look at whatever that 0.3 value was and try to head toward that position. Okay, so that's the basics of PositionFollow. Let's go ahead and move on.